Okay, Aubrey, these are your videos for this week. We're going to do lesson 1, 2, and 3. We're going to talk about rational and irrational numbers, ordering such numbers, and then also talk about square roots and how to estimate non-perfect squares, how to kind of figure out what the square root of a non-perfect square would be. So let's start with rational and irrational numbers. So basically there are two types of numbers, and within these two types of numbers are more specific numbers. A rational number is a number that can be expressed as a ratio in the form of a over b, where a and b are both integers and b is not 0. So like 1/4, or 2 and 1400ths, or 45%, or 4 and 2/5 are all examples of rational numbers. So are negative numbers. Any of these, if you stick a negative sign in front of them, they are also considered rational numbers. Numbers that cannot be expressed as a ratio of two integers are called irrational numbers. Pi and the square root of 2 are examples of irrational numbers. The decimal expression of a rational number terminates in zeros or in a repeated pattern. When a decimal expansion repeats a pattern, draw a line over the repeated portion. For example, 2 over 20 or 3 over 22 written as a decimal. So like if you did 3 divided by 22, you get this. Now, my calculator obviously doesn't keep going, and it doesn't show that it repeats, except for you see 3, 6, 3, 6, 3, 6, and so on. So you would write that as 0.136 with a line over 36, because the 3, 6 is what gets repeated. The decimal expansion of an irrational number does not terminate and does not repeat. So pretty much every number is going to be rational, with the exception of numbers that don't stop. So the decimal keeps going and it also does not repeat. So like in this case, this decimal keeps going, but it starts to repeat. And so therefore it's rational. If it had no pattern like pi, or if it's just a decimal that keeps going with no repetition, it's considered irrational. So find the decimal expansion of 9 over 8. So how do you do that? You divide. So I see how many times 8 can go into 9. It can go 1 time, subtract, get 1, bring down. Or then you put a decimal point and add a 0. So I'm going to just do that out like this. So 8 can go into 9 1 time. That's 8, subtract, and get 1. And then I have a remainder of 1. In order to make that into a decimal, I place a decimal here, and I place a 0, because 9 is equivalent to 9 and 0/10. Then I bring my 0 down. 8 can go into 10, 2 times, not 2 times, 1 time, which is 8, subtract, and get 2. I need to place another 0. 8 can go into 20 2 times, which is 16, subtract, and get 4. Place another 0, 40. 8 can go into 45 times, and then it ends, which means that this is a rational number because it terminates or ends at that 5. Now, if it were to keep going, and you tried up to the thousands place, you placed a 0 in the thousands place to keep trying it, and then it were to keep going, you would still have a remainder down here, and you place another 0. Now, most likely, it's gonna then just keep going. It's not gonna terminate, but sometimes it will. Now, for math in elementary school, most teachers say end it at the thousands place. So place that 0 there, and if it keeps going, just round to the nearest thousands place to get as close to the irrational number as you can. So down here it says, provide an example of a rational number in fraction form along with its decimal expansion. I'm going to use 1/2 because I know that's a rational number. And then I would do 2 or 1 divided by 2. 2 can't go into 1, so I place a decimal point and a 0. So 2 can go into 10 5 times, which is 10, subtract, and get 0. So the decimal terminates, and therefore it is a rational number. Find the decimal expansion of 1/6. So you find the numerator, or you divide the numerator by the denominator, divide 1 by 6 using long division. So 1 divided by 6, I have to place all these zeros. You see they go all the way to the 10,000ths place. So 6 can go into 1, 0 times. 6 can go into 10, 1 time, which is 6. Subtracting it 4, bring down the next 0. 6 can go into 40, 6 times, which is 36. Subtract and get another 4, bring down the 0, and that's 6, which is 40, or which is 36. Subtract and get 4, bring down the other 0. And as you can see, it's going to just start repeating. Therefore, recognize a repeating pattern, rewrite the decimal expansion. So it's 0.16 with a line over it to show it repeats. So 1/6 is equivalent to 0.16 repeating, which means this is a rational number because it does repeat. It doesn't terminate, but it does repeat, which makes it rational. So this question right here says, is 3.491831 a rational number? It doesn't look like it because it doesn't repeat and it doesn't terminate. So decide if the decimal expansion terminates and if it repeats. It does not terminate because you have your ellipses here, which means it keeps going. And it does not have repeating patterns. Does not terminate and does not repeat. So it is an irrational number. It is irrational. What is a rational number? It is a number that written in its decimal form repeats a pattern or terminates or ends. What is an irrational number? Same thing, except for it does not terminate and does not repeat. So a number that written in its decimal form does not repeat or terminate. What are two possibilities for the decimal expansion of a rational number? So we already did 1/2. And then also, let's try 1/3. So 1 divided by 3. So 3 can't go into 1. I place the decimal point. I'm going to move that down so we can see it. So 3 can go into 10 3 times, which is 9. Subtract and get 1. Place another 0. And what you can see is it's just going to repeat. So as a decimal form, 1/3 is written as 3/10 repeated. So is that rational? Yes, it is, because it does repeat. So what you're going to do is calculate the decimal expansion of each number, indicating the repeating decimals in the correct notation. So you can use a calculator for this. I know you know how to take a fraction and turn it into a decimal. You don't need to do the math. You can just use a calculator and determine. So for example, for this 3/4, I'm just going to do 3 divided by 4 equals 0.75, which is rational. And then 2/3, 2 divided by 3 equals, and then if you notice, it's 0.66666. So you can assume right here it's going to repeat. So it's 0.6 repeating, 13%. So you can, obviously 13% turned into a decimal is 0.13. But what you can do is do 13 divided by 100, because 13% is out of 100. So written as a fraction, it's 13 over 100. And to turn that into a decimal, you divide 13 by 100, which equals 13/10. So that's rational, and so on. So to figure out these mixed numbers, I would turn it into a improper fraction. So this is 10/14/5. And then just do the work on the calculator. 14 divided by 5 equals 2.8, which is rational, and so on. So do 7 and 9, and then these say classify each number as rational or irrational. So this terminates, so it's rational. This does not terminate, and it doesn't seem like there's any sort of pattern. Now, if you look at it, it goes 1, 2, 3, 2, 4, 2, 5. Yeah, there's no pattern there, so I would say that's irrational. Here, there is a pattern, so I would rewrite this as 5.716 repeated, which makes it rational. And then here, you've got 0, 2, 2, 0, 2, 2, 0. So is that a pattern? 0, 0, 2, 2. Because then then it repeats 0, 2, 2, 0. So this is rational. It does repeat. Now, I've never seen anything like that when actually working with math, but that is a cool pattern. All right, so you can do the rest of these on your own. To see how you can figure this stuff out. So there's a word problem on the other page, and then express each rational number in decimal form. You can use your calculator to do that, and then explain why each one of these is a rational number. So just look at them. This terminates. This is a whole number which terminates. This repeats, and then you got to figure out how this is in a decimal form, and then explain why it's a rational number, and then you have 2 word problems.